Dun 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 dun. The mole. The mole. Okay. Good afternoon, everyone, and welcome back to chemistry. We're talking about the mole again. This time, we're going to do a little bit of math. Now, I realize math is not everyone's favorite thing in the world, but we're going to try to make this pretty straightforward. I can convert back and forth between a couple topics pretty simply. I know I can go into my cabinet and I have a jar of pennies. I don't know why I keep them. I can't spend them on anything. I should just like throw them away or melt them. I know, I'm just kidding. But anyways, if I go, I can actually count the pennies. I could weigh the pennies to find their mass, right? And here's the thing. Basically, pennies are pretty much all identical. They have about the same mass. So I want you to think about this right now. Would there really be any difference between counting the pennies versus weighing the pennies? I mean, if I knew the mass of a single penny and then I weighed the entire thing, couldn't that tell me how many pennies there were? So I think if you think about that a little bit, there's not that much difference between counting pennies and actually weighing them. And it turns out that it's exactly the same relationship when we talk about atoms and moles. I can count how many atoms I have, or I can weigh the number of atoms. They're really going to tell me the same thing. So let's pick a nice round atom. We might as well pick copper. I like copper. I don't know why. I just do. So copper has a mass, if I assume 1 mole of material, of about 63.5 grams. So that is what we call molar mass. Now, you're going to see this written like this. You're going to see it written as a fraction. 63.5 grams per mole. And remember, this whole thing right here is whenever someone says molar mass, that's what they're talking about. So 63.5 grams per mole. And you could also say if it's grams per mole, it's the same as 63.5 grams per 1 mole of material. Isn't that also true? Okay, fine. So this is the molar mass of copper. And you know from last time, you know how to find the molar mass of not just an element, but from any compound. Well, what if I didn't give you exactly 1 mole of material? Let's say right now I'm going to go crazy. I want to give you, let's say, half a mole. Now, let's go crazy. Let's say 0.71 moles. I actually only give you 0.71 moles of copper. Can you now tell me how heavy that's going to weigh? Well, I want you to think about it like this. You basically know how heavy 1 mole of copper is going to be. So do you think a fraction, 0.71 moles of copper, is going to weigh the same as 63.5? You want to get a minute to think about it? You're thinking? Okay, just kidding. So, of course, 1 mole weighs this. So if I only have 0.71 moles, it can't weigh as much. So how do I go and find out? Well, I'm going to set it up like I set up a unit conversion. Oh, unit conversion, it's not that bad. So I'm going to set this up like a unit conversion, and I'm going to take this number and put it over 1 just for fun. And like any unit conversions, I need to multiply something that's going to cancel out moles of copper. So watch this. Do I know anything about copper right now? I do. I know that 1 mole of copper is going to contain 63.5 grams of copper. So watch this. If I take this entire thing and multiply it by the molar mass, I'm going to get my answer. So I know that 1 mole of copper is going to have a mass of 63.5 grams. 63.5 grams of copper in 1 mole of copper. So what units are going to cancel out for us? Basically, moles of copper cancels out, and the unit that's left is grams of copper. So now I can do a little math. I can take 63.5 times 0.71. Let me pause this so I can do that. Okay, and we're back. And that tells me that if I put my answer over here, 0.71 moles of copper is going to have a mass of 45 point, and I'm going to round it to 1, 45.1 grams. And that should make sense. Look, this is about 3/4 of a mole. 3/4 of something can't have the mass of the whole thing. 45.1 grams is about 3/4 of that, okay? All right, so far so good. Well, let's go crazy. Okay, we're back. So let's go crazy with this. Let's say instead of giving you a certain number of moles, I'm going to give you a certain number of grams. I'm going to give you 3.7 grams of copper. Can you go and convert from how heavy that is to how many there are? Can you convert from grams of copper to moles of copper? And the answer, of course, is yes. I'm going to show you how to do this. Take your answer. Sorry, that's not your answer. Take what you're given. You always take what you know. I know 3.7 grams of copper, and I can put it over 1 just for fun. And I need to convert it to moles of copper. Now, here's your conversion factor. It's right there. I know that there are 63.5 grams in 1 mole of material. Now I have to take this and put it down here top and bottom in a way that's going to cancel out grams of copper, right? So there's only one way that's going to happen if the 63.5 grams is in the bottom. So here we go. 63.5 grams of copper. Now I know a lot of you are not going to want to write down these units on the top and bottom. A lot of you are just going to want to write down numbers, and that's okay, but I do recommend writing everything out because in the long run, I think it helps you more, especially in another week or so. So we've got 3.7 grams of copper over 1 multiplied by 1 mole of copper over 63.5. Let's just do a check. What cancels out? Grams of copper cancel. It leaves us with a unit of moles of copper. So now I've got a division problem. I've got 3.7 divided by 63.5. So let me pause for a minute to get an answer. Okay, and don't be surprised, you should get a small number here. This is 0.0, wait for it, 5.8 moles. Does that number make sense? And that's moles of copper. A lot of people look at this and they're like, you're a little bit unsure because this number seems a little small. It's so small it seems wrong, but it's actually okay. We're not talking about an entire mole here. Remember, 1 mole of material contains 63.5 grams. You're given a small fraction of that. You're only given 3.7 grams. So we're not talking about a full mole. So our percentage here is not that. So if you turn this number, I know it's a mole right now, but if you turn this back into a percentage, you multiply it by 100, we're talking about 5.8%. If you think about it, 3.7 grams is kind of like 5.8% of 63.5. So we're okay. All right? All right, cool. Let's try something even crazier. Okay, so this is as crazy as it gets. Let's say I'm going to give you another number here, and I'm making this one up. What do you want me to go, high or low? High or low? All right, I'm going to go high. Let's say I have 571 grams of copper, and that's a lot of copper. Can you convert this from grams to, wait for it, atoms? And this is where people are like, no way, this is not even possible. I want you to just stop and think about this a little bit. Think about what you know. You know that you can convert right now between grams of something to moles of something. And grams is really how heavy something is, moles is how many. Can you tell me how many of anything are in 1 mole of anything? What do you think about that? Yeah, so the wheels are turning. You're probably saying, wait, I know that 1 mole of anything, even fruit flies, I could have a mole of fruit flies, is equal to 6.02 times 10 to the 23. 1 mole of anything contains 6.02 times 10 to the 23 of anything. I think I spelled anything wrong, but there you go. It's close enough to anything. Anything. 1 mole of anything is 6.02 times 10 to the 23 of anything. So here's how we're going to set up this problem. I need to convert from grams to moles. I always have to go from how heavy something is to how many. And then once I have how many to moles, I'm going to convert to individual to atoms. So watch this. I'm going to set the whole thing up as an equation. I'm going to take what I'm given, 571, whoops, 571 grams of copper, and I'm going to put it over 1 just for fun. And now I have to convert that from grams to moles. And here's our conversion, 63.5 grams per 1 mole. So now you know from the last problem that grams has to go in the denominator, the other numerator, right? The denominator is the other numerator. Do you buy that? Okay, I'll stop talking now. Anyways, 63.5 grams of copper, and I'm going to extend my line a little bit, and that is in 1 mole of copper, and that's the first part of the problem. And now I'm going to multiply it again by something else. So this part of the problem just canceled out grams. Now, a lot of you are like, oh, wait, don't I have to stop and get an answer before I go on? Technically, no. I like to kind of keep going on. So now we've got moles of copper. I want to get to atoms of copper. So what's the next step? Well, I know that there's 1 mole, in 1 mole there's 6.02 times 10 to the 23 of anything. So guess what? I'm sorry, anything. That's what has to go in here. Watch where I'm going to put it. I got to put moles in the bottom. 1 mole. And I'm going to, just to make the units work, I'm going to say 1 mole of copper, right? So it'll cancel out with the mole of copper here. So 1 mole of copper contains 6.02 times 10 to the 23 of anything. Now, I'm sorry. In this case, because we're talking about copper, it's 1 mole of copper is 6.02 times 10 to the 23, the copper atoms. Like how I said, atoms. So here's our problem. Let me extend this line a little bit because it's bothering me. So now I've got some cancellation I can do. 1 mole of copper cancels with 1 mole of copper. The only unit I have left is copper atoms. So now we've got a math problem. So take a minute, punch that into your calculator, and be right back. Okay, you back? You ready? So here's our answer. I'm going to plug this in right here. I'm going to actually put the answer here because I'm running out of space. So my answer is 5.4. 5.4, and the next one is actually a 4 times 10 to the 24. So that's how many copper atoms, and that's Cu atoms, and I'll spell atoms with a Z just because it looks cool. That's how many atoms are going to be in 571 grams of copper. Now keep in mind, I always like to put this in perspective. There's 454 grams in a pound. And what's a good sized pound? A good sized pound is like a softball. Softball is like a pound, right? So we're talking 571 is a little bit more than a pound. All right, it's more than a pound. So we're talking about a pound of copper atoms. This is how many copper atoms there's going to be in about a pound of copper atoms. That's pretty cool. So look, just to sum things up, we talked about 3 different things here. We converted from mass to moles, we converted from moles back to mass, and now we did like the grand finale here, converting from grams all the way to atoms. Now these are calculations you can do. You have to take your time. You have to, and like I said, I really think you need to be writing all this stuff in to help you cancel stuff. If I come to help you out with a paper and you just have numbers in here, it's so easy to get confused. All right, listen, this takes practice. Hang in there and you'll get it, okay? Have a good one. See ya.